Welcome to this session. Today I'm going to show you how to build a Go serverless REST API with AWS. I opened my IDE, I used Golang, and I created a directory which is named serverless-rest-api. So the first thing that I'm going to do is that I'm going to initialize my module, my Go module. So I'm going to type go mod init and then my module path. So it's going to be github.com/Maximilien Endile /serverless-rest-api. And I'm pressing enter. And you can see that we have this message, so it means that a go.mod file has been created. And you see you have my module path and then the Go version that I'm using. I'm using Go 1.19. The next step is to create a new main file. So I'm creating a new file named main. So it's going to be main.go. And you can see that my IDE has automatically added package main and then the function main. So the function main will be the entry point of our program. So I can just do a small hello world to verify that it works. So fmt println hello world. Then I can run that application. I type go run main.go. And the application will be compiled and it will be run. Okay, we might want to do something else than a simple hello world. The first step will be to install a Go module which is named Gin. So I'm going to open my Internet Navigator and then I'm going to search for Gin GitHub. So on GitHub you have many modules that are available and one that is named Gin. So Gin is an HTTP web framework which is written with Go. And this is what we are going to need to develop our application. So I'm going to install it on my application. So you have the installation instructions. So it's go get -u. -u enables you to download the latest version. So I'm using that. I'm copying that. And then I put that into my terminal. So the latest version will be downloaded and my go.mod file will be also updated and my go.sum file will be also updated and created, by the way. So here you can see it here. So I have the go.mod and the go.sum. Then the next step will be to use that library. So as always, when I install a new library, I take a look at the README in order to see the quick start. So there is usually an example on how to use it. And then I'm going to copy that and then paste it. All right. So, by the way, you can see that my IDE has detected that I want to use the package Gin that comes from that module. So it has automatically added the import statement here. That's one of the main reasons to use an IDE is that you don't have to write it by hand. If you're not using an IDE like Golang or VS Code, you might have to write it by yourself. So what it does. The first function that is called is the default function from the package Gin. So default will return an engine instance with the logger and recovery middleware already attached. So it will return a new default server with logging and recovery. Recovery, it means that when your application will panic, will have a runtime failure, it will recover. It will not stop the application, but it will allow your application to keep running. So here I'm creating a default engine, and then I can define my route. So here it will be a get route, so get/ping, and here you have the handler that will be executed. So this function will be executed when we will have a request on the /ping route, get/ping. And then air.run will attach the router to an HTTP server and start listening and serving HTTP requests. So here my server will run. Let's compile and run this program. So go run main.go. You can see that you have an alert. Do you allow the application main to accept incoming network connections? So you're going to press allow. This is a security feature of macOS. I'm on macOS. I'm going to allow that. So then I have my server that is listening on this port 8080. Take a look at the logs that we have. So we have one root get/ping, and it's going to be linked to a main.main. So package main inside the main function and the function one. Function one, it's a name that is by default because we don't have really a function. We have an anonymous function here. It's still a function, but anonymous. All right. Then I'm going to open my navigator, so Chrome, and I'm going to try to ping that server. So localhost 8080/ping. All right, so I have message pong here that is written. So when I get /ping, I have this response here. So JSON response with message and pong. And so it works as expected. And you can see also in the logs that we have the request that is logged and the time it took to handle the request. All right, good. All right, so now I have a Go application that runs a web server that will accept incoming HTTP request on the port 8080 and that has one root get/ping. It runs on my local. I want to deploy that to the AWS cloud in the serverless mode. So to do that, I'm going to use the serverless framework. And I'm going to show you the homepage of that application, so serverless.com. But we will need to have NPM installed on our machine. So NPM, this is the dependency management soft that is used in the Node.js community. So first, if you don't have Node installed on your machine and NPM installed on your machine, you will need to install that. So go to nodejs.org and then install the latest version. So here you have the LTS or long time support version. So you install that and you will have Node and NPM on your machine. Because I already have that, I don't have to install it. The next step is to install serverless, and serverless is installable via npm. So we're gonna have this command. So npm install -g serverless. So it's going to install globally serverless on our machine. So I'm going to copy that and I'm going to open a terminal and then I'm going to paste that command and then press enter. When the installation of the serverless framework is finished, you're gonna see this. Here you can see that I have a notice. It means that I have not the latest version of npm installed. Anyway, serverless has been installed. So in order to check that serverless is installed, I'm going to type serverless and then version. And you can see that I have an error because the command version is not found, but still I have an error that is from the serverless framework. So I can run serverless -- version, maybe it's better. Yes, so serverless -- version will get you the version of the framework instead. So here I have the version 3.24.1, etc., etc. So now we are ready to initialize our project with the serverless framework. Let's go back to your IDE. I'm going to add a new file that will be named serverless.yml. It's a YAML file. So YAML file is a particular format of file. And so in that file, I'm going to describe what I want to deploy into the cloud. And it will be used by the serverless framework in order to deploy what we're going to work on to the cloud. So the first thing that I want to add is service. And then I add a colon, and I'm going to add my service name. So it's going to be serverless REST API, like project name, but you can put whatever you want. Then I can define the framework version. So you type framework version and then a colon, and then you define the version of the framework that you are going to use, so the serverless framework. So here I'm going to type 1.18.0 that allows you compatibility with previous version of the framework. Then I will have to define the provider that I want to use. And here I have to define the provider by name. So I'm going to say that I want to use AWS. So I have a provider key, then a name key, it's AWS. After that, I will have to specify the runtime that I want to use. And I'm going to say that I want to use the runtime go1.x. And you can see that I have autocomplete here in my IDE. That's because I've certainly added a plugin for serverless. Then I define the region where I want my application to be deployed in AWS. If you remember, AWS works with regions. So regions are large data centers. So you have many regions. I'm going to select one, which is EU Central-1. Then I will add to provide the stage. So here I'm going to say that I want to provide that with the command line interface. So I add a $, then curly bracket, then OPT, and then stage. And then I close the curly bracket. So I'm going to provide the stage by command line. I can also write that directly here, hard-coded here, but it's better to have that provided by the command line interface. So after the stage, we need to define our serverless functions. So we create another key, so functions, and then we're going to define all our functions. So for the moment, we will have just one function, and we will name that function API. When you define a function, we need to define a handler. So for the moment, and we'll just put X here. We're going to change that later. And then you need to define the events that will trigger your function. So for the events, I'm going to put as well XXX here, and we will complete that later. And then I'm going to add a new file in my project, and this file will be named makefile. And be careful with the naming, you have to start with the big M. The makefile will help us to run commands in order to deploy our application to the AWS cloud. So what is a makefile? A makefile is a textual file where we define rules. And each rule has a target, which is equivalent to a name. I'm going to define a first rule, and let's call that build. And in this rule, so I add a tab here, a colon and then a tab, and I'm going to define the instructions that I want to run. Each rule has what we call a receipt, which is composed of a set of instructions. And do not forget this tab. So here I'm going to put my build comment. So I'm going to type env, then go os equal Linux. So I'm setting an environment variable named goOS, and the value will be Linux. And this environment variable will allow us to compile our Go program for the Linux environment. And then I type go build. Then I'm going to add some linker flags, so -ld flags, and then equal -s and -w. I'm going to explain that later. So what does it mean exactly? So go build, I'm building the program, and then I say that I want to build that into the directory bin, and my binary will be named main. And what do I want to build? I want to build the file main.go. So I want to build for Linux, so I'm setting goOS to Linux, and then I have this command, so go build, and then some linker flags, and I set my binary name, so the file that will be created by the compiler, it will be put into the directory bin, and it will be named main, and I want to compile this main.go. So it will compile that and put that into the bin directory. So I'm going to create a new directory here named bin. Okay, so let's test that. So I hit Control C in order to stop the server, and then I'm going to type make build. So you can see that it displays the command that it runs. And you can see now that we have a new file that has been created in the bin directory, and it is our main file. So it is our binary. So let's say that I want to run it. So I'm going to type in my terminal ./bin/main. And you can see that we have here an exec format error. That's because we have a binary that has been made for Linux, and I'm on Mac, so that's normal. That's totally normal. Now that I have my compilation instructions that are on my makefile, and I'm able to compile my Go program, I need to say to Serverless, what do you need to put and push into the AWS cloud? So to do that, I'm going to add a key, which is named package. And in this key, I'm going to set the things that I want to package and things that I don't want to package. So things that I want to include and things that I want to exclude. So before there was a previous notation with exclude include. Now it's using this kind of notation. So I'm gonna just copy this one, and we're gonna put that into our serverless file. So by the way, the serverless framework has a great documentation, so you can go on frameworks /docs. So I'm pasting that here, and so I want to exclude everything, and then I want to include only what is inside bin, and particularly I want to include bin/main. So the first line is for exclusion. I said that I want to exclude everything. So note here the exclamation mark. This is for exclusion, and I want to include that. So I exclude everything, and I want just to include that. So bin/main. So this file will be included and pushed into AWS. And now there is something that we can define now. So we have a function named API, and this function has an handler which is equal to x66. We can remove that and put bin/main. Handler, this is the program that will be executed when your function is called. So we want to execute bin/main. And now the next question that we have to answer is, what are the events that will trigger our function, that will launch our program? Events is a list, because you can have many events that trigger the same function. So I'm going to remove the x66, then press enter, and then have dash, and we will have a first HTTP event. And this HTTP event, we will need to define here the path. So we will define the path /ping, and then we will need to define the method. And the method here is get. By the way, you can note here that what I've defined here, get/ping, this is the same as in my main function. You can see here that on my Gin server, I say that I want to have a route that is get/ping. So now I have my serverless file. In that file, I say that I want to use the provider AWS, and I want to create a function that is named API that uses this handler and react to these events. And I also give instruction to package my program. I have everything needed in order to deploy, but we need to deploy, and to deploy we will need to input a command into the terminal. In order to make our life easier, we will add another receipt to the makefile. We're going to name that deploy_prod, and so we add a colon, and then with the makefile we can say, okay, please run that before running the command that I'm going to give you. So I'm going to say that I want to run first build, because I need to build my Go program, I need to compile it. And then I can actually run the command in order to deploy with serverless. And so it's serverless deploy. Then I have to specify the stage, and I say that I want to deploy in prod. You can say --stage and then prod. You can find it here. Here I have an option, command line option that I've set up, and this will be replaced by prod when I run this command. And then there is something specific to AWS. I want also to say that I want to use a specific AWS profile. If you don't input that, it will be your main credentials will be used. But if you have many credentials, you can also set up your AWS profile. So to do that, you just type --AWS-profile. And so on my computer, it's named Max ALD Tools. So I say to Serverless, please use this profile when you deploy this application. It's pretty useful when you have more than one profile and you have this AWS account, another one for another project, etc., etc. There is some documentation online that you can find in order to set up those profiles on your computer. Basically, you will have to create a new file and then you can set up different AWS profiles. I'm going to put the link to that documentation in the video description. All right, so now we can run our command. So by the way, I opened a new terminal because I think this one is a bit slow. So I'm gonna just type the command in that new terminal, but it's the same as if I type it here. Don't be confused. So I'm gonna type make deploy _prod, and we will see what happens. So you can see that I have first the compilation that will take place and then this command. So the first step is to create a CloudFormation stack. We will see later what it is. So when you see that on your terminal, service deployed to stack, blah, 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 it means that your service has been successfully deployed to AWS. And you can see that we have the list of endpoints. So for the moment, we have just one endpoint. It's this endpoint. So I'm going to copy that and test it. To test it, I'm going to use curl. So with that, I can type in my terminal curl and then paste the URL to my endpoint. And then I press enter. You can note that we have a bit of latency, so it's not a good news. And then we have this message, internal server error, so something wrong happened. We will have to debug that. In order to understand what's wrong, we will have to check the logs. So connect to the AWS console, so you log in on your account, and then make sure you have selected the right region. So here I select EU Central 1, which is Frankfurt. And then I click on CloudWatch, so you can also search here for CloudWatch. And we're gonna click then on log groups. And on log groups, we should see our log group for our function. So I'm going to type the service name. And you can see that I have a log group here, so Serverless REST API prod API. Let's take a look at one log stream. So you can see here that we have logs from our application. And you can note that we have the same logs that we had in local. So we have the gin debug, we have the get/ping that is created. And then the idea is to search for the error that we have. You will see that in the logs that you have some messages that start with start and then a request ID. And here you have a message that is not from our application, apparently. And then you have end. So here means that you will have the message, the error message for a specific request. And you can see that our task timed out after 6 seconds. So that's why we had a little bit of latency, the 6 seconds latency, and the task just timed out. So it means that we are not handling requests correctly on our application. Maybe our application is not well formatted and doesn't fit into what AWS expects. Let's take a look at the documentation for the Lambda function and specifically the documentation that is written for Go developers. You can see an example here. So we have the package main, and inside the function main, you can see that they use this package, Lambda, that is from this module, so github.com/aws/aws lambda go, and you can see that they are calling the start function, and they give to this start function another function which is handle request. So here is a mistake. We have to format our code like that. So the first thing to do is to install that. So I'm going to copy that and go back to my IDE, and then I type go get and that. You can see that it has been added to our project. Now we're going to mimic what they do. So because we have some stuff in the main, we can put that into an init function. So the init function will be run before everything else. So let's put that into our init function. I'm going to remove the run, and then I'm going to mimic what is done here. So it's lambda.start and then handle request. Let me copy that directly. So then I have to say that I want to import context. I'm going to import the package from the standard library, so context. And you can see that we have to define here an event. So in the example, the event is a type that they have created, but our event is an HTTP request. So it's not going to be my event, it's not going to be something custom that we're going to create. It is going to be a type that is provided by the AWS SDK for Go. So there is a package in that SDK that is named events, and inside that package we have many events. You can see you have extra events, Cognito, etc., etc. And we will use the API gateway proxy request as input, and the output will be events, not request, but API gateway proxy response. Why do I put that here? That's because when we have deployed to AWS, Serverless has created an API gateway. So whenever my Lambda function is called, I will receive this, so an event API gateway proxy request, and I will have to send back an API gateway proxy response, request response. And so you can see that this is not good because we expect to have an API gateway proxy response. So let's do a quick test, and we're gonna send an event API proxy response. Let's take a look at that type, and you can see that we can define the status code, we can define the headers, multi-value headers, the body, and boolean which says is it a bash/cat encoded or not. Let's, for the moment, I'm gonna just send a status code which is equal to 200, and maybe the body as well. And for instance, the body will be fmt sprintf hello world, or just hello world. Okay. Then I can leave it like that, and we can make a test. So let's deploy again. So because we have modified the application, we're gonna deploy again. So we use the make command. So make deploy prod. After less than a minute, we have the application that has been redeployed. So let's try again to do this curl. So by the way, the URL has not changed, so it's still the same. So I'm going to enter and press curl, and you can see that we have the feedback hello world. That's good. So that means that our API gateway is responding, and this is our program that is responding. Great. But now we have to wire our Gene web server with this handle request function. In order to do that, we will use something that has been developed by the AWS labs, and it's called the Gene adapter. So this project is hosted on GitHub, so it's github.com/AWS labs/AWS-lambda-go-API-proxy. And you can see that it covers all web frameworks that you have in Go, most of them, and especially Gin. And here you have an adapter that allows you to wire your server with this handle request function. So let's install that. So I'm going to copy that. So github.com/AWS labs/AWS Lambda Go API proxy. And then I go back to my IDE and I type go get and that. Okay, so it has been added to our modules. So now we can use it. Then we can use this module. So let's refer to the README. And as you can see in the README, you have a section for G. So you can see, by the way, that they have the same construct as me. So an init function where I create a Gin default server, then they have the ping. But they create here a global variable that is called Gin Lambda of type pointer to Gin adapter.Gin Lambda. So I'm going to add that to my program. And here you can see that they set Gin Lambda which is equal to Gin adapter.new, and it takes dngine as input. Gin adapter.new, and it takes dngine. So we have Gin Lambda set inside the init function, and then inside the handler, I'm going to copy that. So I replace that by this one. And so it takes as input a context and an events.API gateway proxy request. So let's rename that input variable from name to rec. And then it looks good. Then we can recompile and deploy. So same as before, I use make deploy underscore prod. After 43 seconds, my service has been deployed to the cloud, and now it's time to test it. So I'm using the same curl command, and let's see if we have the pong. That's awesome. Our API gateway linked to the Lambda function is working. Let's take a look at what has been created in the cloud when you run serverless deploy. So to check that, you go to the console, and then you select the service CloudFormation. Then you are going to select the appropriate stack. So everything in CloudFormation is a stack, and you can have many stacks, and you will have one stack by service cross stage. So here, this is my service, serverless-rest-API, and here, this is the stage. So this is the prod stage. And you can see here that what we have is an API gateway deployment, an API gateway method, an API gateway resource, REST API, then a Lambda function, permissions related to the Lambda function, versioning, AWS Lambda version, a log group, an IAM role, an S3 bucket, and an S3 bucket policy. Let's make a brief summary of what has been created in the AWS cloud for this service. So you, as a developer, you are going to use serverless. So when you type in your terminal serverless deploy, serverless is going to create a CloudFormation stack for you with everything you need in order to deploy your service. Then it's going to push your code, your binary, so the result of the compilation of the Go program, into an S3 bucket. And this binary is going to be injected into a new AWS Lambda. And again, everything is handled by CloudFormation. So you will have a Lambda that will have your Go program loaded in it. And this Lambda might also create some logs, and so it will create some logs into a specific log group that will be created in Amazon CloudWatch. And so from the point of view of the client, so when somebody is going to request your API, they're going to send an HTTP request to an Amazon API gateway that has also been created by the CloudFormation. And this API gateway will pass the request to the Lambda function where your code will execute. There is another thing that we can do in order to make our API perfect is to set up a custom domain name. So instead of having execute dash blah 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 blah, we can have api.yourdomainname.com set up, and that will route the traffic from this specific domain name to your API gateway. It requires too much time, so I will create another video in order to explain how to do that. Stay tuned. Thanks for watching. I hope that you have learned something from my video. Some of my links: practicalgolessons.com. This is a book about Go, and you can read the online version for free. You can also support me by buying the digital or the paper version. I also have a Go course on that website of 32 hours to build a full-featured website with Go and Vue.js, and then my social networks, where I try to share content around Go and programming, so you can follow me on Twitter, on LinkedIn, and also on YouTube. Thanks again, and see you next time!